Water. Why does it matter? Water is pretty darn important for our living things. Your body is more than one half water, and if we were to take a look at your cells, we'd find they were over 70% water. So you, like most land animals, need a reliable supply of fresh water to survive. Of the water on the earth, 97.5% is salt water. Of the remaining water, over 99% is in the form of underground water or ice. All told, less than 1% of fresh water is found in lakes, rivers, and other available surface forms. Many living things depend on this supply of surface fresh water, and lack of water can have a serious effect on ecosystems. Humans, of course, have come up with some technologies to increase water availability. These include digging wells to get at groundwater, collecting rainwater, and using desalination, salt removal, to get fresh water from the ocean. Still, clean, safe drinking water is not always available in many parts of the world today. Most of the water on Earth does not cycle, move from one place to another very rapidly. We can see this in the figure below, which shows the average time that an individual water molecule spends in each of Earth's major water reservoirs, a measurement called resident time. Water in oceans, underground, and in the form of ice tends to cycle very slowly. Only surface water cycles rapidly. So what it's saying is if you see any water in oceans, any of our groundwater, which is our water that we can find, like it said, underground, we cannot see it. And water that is in the form of ice, that's going to cycle through the earth very slowly. Only the water on the surface is going to cycle rapidly. So that's where we could see the majority of the water cycle, which we're going to talk about now. The water cycle. The water cycle is driven by sun's energy. The sun warms the ocean surface and other surface water, causing liquid water to evaporate and ice to sublime, turn directly from a solid to a gas. So the sun's energy is causing the liquid water to evaporate, and then the ice just to go from ice to a gas and evaporate as well. These sun-driven processes move water into the atmosphere in the form of water vapor. Over time, water vapor in the atmosphere condenses into clouds and eventually falls as precipitation, rain, or snow. When precipitation reaches Earth's surface, it has a few options. It can evaporate again, flow over the surface, or percolate, which means sink down into the ground. In land-based or terrestrial ecosystems in their natural state, rain usually hits the leaves and other surfaces of plants before it reaches the soil. Some water evaporates quickly from the surfaces of the plants. The water that's left reaches the soil, and in most cases will begin to move down into it. In general, water moves along the surface as runoff only when the soil is saturated with water. That saturated means that it can't hold any more water. When rain is falling very hard, or when the surface can't absorb any more water. A non-absorbent surface could be a rock in a natural ecosystem, or asphalt or cement in an urban or suburban ecosystem. So as you can see down below, the wonderful graphic shows the water cycle and all the different ways that water can evaporate up into the sky, how it forms clouds, and then how it eventually comes back down to the ground through precipitation. That could be in the form of rain, hail, snow, all those things. Water in the upper levels of the soil can be taken up by plant roots. Plants use some of the water for their own metabolism, and water that's in plant tissues can find its way into animals' bodies when the plants get eaten. However, most of the water that enters a plant's body will be lost back to the atmosphere in a process called transpiration. In transpiration, water enters through the roots, travels upward through the vascular tubes made out of dead cells, and evaporates through the pores called stomata found in the leaves. So this is another way that water can evaporate. Okay, so it can evaporate through plants. You have the plants taking in the groundwater through their roots, and the water is going to travel up through the plant, reaching the leaves, and then through there the water will evaporate. If the water is not taken up by the plant roots, it may percolate down into the subsoil and bedrock, forming groundwater. Groundwater is water found in pores between particles in the sand and gravel or in the cracks in rocks, and it's an important reservoir of fresh water. So if you think about, where do I get my drinking water from? A lot of people who live out in the area you guys live will think, well, we get our drinking water from Lake Michigan. Well, that is not true. You guys actually get your water from groundwater, your drinking water from groundwater. Your groundwater is kind of holding itself in these underground caves called aquifers, okay? So we're getting our drinking water from our groundwater. Some groundwater lies deep in the bedrock and can stay there for millennia. Groundwater reservoirs or aquifers are usually the source of drinking or irrigation water drawn up through wells. Today, many aquifers are being used up faster than they're renewed by water that moves down from above. And another important thing to think about, since we get our drinking water from groundwater, think about all the chemicals, the pesticides, litter that you throw on the ground. So when that stuff gets wet, it's going to absorb into the ground and seep down into those cracks and those pores and those caves underground, in which we're going to drink. So that's another thing to think about before you litter, or before you pour your can of soda, or anything that could be harmful onto the ground, because you think, oh, it's just going to disappear. It's not going to disappear. If it rains, it's going to saturate the ground and then seep. All those chemicals and harmful things can seep right into our drinking water. So that's something really important to keep in mind too. The water cycle drives other cycles. The water cycle is important in itself, and patterns of water cycling and rainfall have major effects on Earth's ecosystems. However, rainfall and surface runoff also play important roles in cycling of various elements. These include carbon, nitrogen, phosphorus, and sulfur. Those are the elements that we talked about last time. Those are an integral part of the biogeochemical cycle in our Earth, and how important that is for just maintaining life on Earth. In particular, surface runoffs help move these elements from terrestrial land-based to aquatic systems. So the water cycle is moving all these super essential elements to all the different types of ecosystem in our entire world. We'll take a closer look at how this works in the following articles, where we'll examine different elements' biogeochemical cycles. So after this, the activity is for you to make your own water cycle. So the directions have been put in Google Classroom. It is super simple, but also super cool. All you need is a plastic bag, a piece of tape, and a marker, and a window, which I'm sure all of you have in your house. So I would love to see some pictures of those. Post those up on the Classroom website.